Right, in this lesson, we shall focus on mathematics paper one, and we shall ensure that we go through the necessary concepts that um, are covered in the first paper. This is a 3-hour paper, and therefore this 3-hour paper is to be written obviously in 3 hours and out of 150 marks. All right, so yeah, let's get to it. Okay, let's get started. Right, first things first, we are looking at the most basic of questions, how to solve for x. Given the quadratic equation, so we're looking at 1.1.1, given x squared plus x minus 12 equals 0. Right, we're not going to waste a lot of time there. The factors of x squared become x and the factors of 12 become exactly minus 3 together with plus 4, from which we're able to see that x equals 3 or x equals minus 4. So that is exactly how you could do 1.1.1. Next, we're going to look at 1.1.2. Right, in the second question, we look at the quadratic. Right, the quadratic to two decimal places is actually 3x squared minus 2x equals 6. And this is actually 3x squared minus 2x minus 6 equals 0. And from which we're able to see that x equals minus b plus or minus the square root of b squared minus 4ac all over twice a. So this is minus into minus 2 plus or minus the square root of b squared, which is 2 squared minus 4a, and c is exactly that, divided by twice a, which is 3, like so. Right, at this point, we continue to simplify these, and I know that these can be simplified with utmost ease, and therefore x becomes 2 plus or minus the square root of whatever is under the square root sign, and we can launch. Let's launch our calculator. Let us launch our calculator here and be in a position to do whatever is under the square root sign. At this point, we're going to have exactly minus 2, and we square that. Okay, having minus 2, we square. Okay, dealing with what is under the square root. And then we have exactly a minus 4, open bracket, 3, close bracket, open bracket, minus 6, close bracket, and the result is what? Okay, right. So we're able to see, therefore, that the result is exactly 76 under the square root, and that is what we write down. So it's exactly 76 under the square root, and we divide by 2 times 3, which is exactly a 6 there. At this point, we continue to realize, therefore, that our x is 2 plus the square root of 76. We divide by 6, or x is 2 minus the square root of 76. We divide by 6. Right. And at this point, we are able to see what the results are going to be of this one here. Right. So the one with the plus is going to be 1,79. And the other one is going to be minus 1,12. Okay, so these are the answers correct to 2 decimal places there. And we have solved the question 1.1.2. Let's look at the next question, 1.1.3. Right, 1.1.3 is the next question on the radar, and that one is very straightforward. Just a walk in the park. We're able to realize that we have the square root of 2x plus 1, which equals x minus 1, from which we have exactly 2x plus 1 square root. We square both sides. So the objective of squaring both sides is to remove the square root sign, from which we have 2x plus 1, and we square x. We have x squared, x times minus 1 times 2, which is minus 2x plus 1. x squared, we transpose the 2x, getting exactly a minus 4x equals 0 because 1 and 1 cancel out. And that is very, very clear. Right, we take out the highest common factor, which is x, which is the highest common factor of the two terms. At this point, we're able to get that x is 0 or x equals 4. Right, clearly when x is 0, you put it here, it becomes 0 minus 1, giving us a minus 1, meaning the square root is a negative 1, and therefore this is not the case. So this is not applicable, and that is the only applicable result. And therefore, as a consequence, because x equals 0 is not applicable, we actually conclude, therefore, that x is not equal to 0. X can only be 4, because if you put 4 here, 4 minus 1 is 3. And if you put 4, 2 by 4 is 8 plus 1, 9. The square root of 9 is 3. And if you put 4 minus 1, it's also 3. 3 equals 3. The number 4 satisfies the original radical equation, and therefore we have solved the problem in 1.1.3. Next. Right, I want us to discuss briefly how to deal with the quadratic inequalities, and we have this one, and we have x squared minus 2x minus 3 is strictly bigger than 0, from which we have x minus 3 into x plus 1 is bigger than 0. We have things we call the critical values, right? So having the critical values, so we're able to see that x is 3, x is minus 1, and we actually, therefore, are in a position to look at the fact that our x is minus 1 are together with 3, and we have x over there. Okay, next, we realize, therefore, that we're interested in the part with the quadratic is strictly bigger than 0. Strictly bigger than 0, it means that it is not equal to 0. So we put open circles here because it is 0 here, and we put open circles because it is 0 there. But we're looking at greater, so we're going above the x-axis. Now, at this point, we're able to see that x is less than minus 1 or x is bigger than 3, like so. Right, so we're good. Next question, we'll look at actually 1.2. Right, now, solve for x and y simultaneously. We need to solve for these particular simultaneous equations. And to solve them, we write first the equation x plus 2, which is 2y. And we can see, therefore, that x is equal to 2y minus 2. And we get the first equation. Okay, what have we done? We took the 2, we transposed it to the other side, and it became negative. Right, simultaneously, we have the second equation. The second equation is 1 on x plus 1 on y, which is exactly 1. Let's take a look at this. Right, if it's 1 on x plus 1 on y, and the result is equal to 1, what does this mean? Well, at this point, what this means is we take the LCD. LCD is the xy. So the xy means that we take xy, we multiply the first term, and we take another xy, we multiply the second term, and we take xy, we multiply the right-hand side. The LCD, called the lowest common denominator of this, is the product of the denominators. And this, at this point, it is xy. Well, obviously, I mean, the product of the denominators in general is not the lowest common denominator. Okay, but at this point it is. And therefore, x cancels x, because if you multiply here, x is going to cancel x because this x is in the numerator, giving us a y. Plus here, y cancels, giving us an x, and this is xy. Call this one the second equation here. What you do is you substitute. Right, so you substitute equation, right, substitute equation 1 into the second equation. Okay, so now equation 1 is x equals that. So wherever there is x, we're going to put 2y minus 2. So you have y. Here there's x, so you're going to put 2y minus 2. Here there's x, we put 2y minus 2, and the result is y. All right, so y plus 2y will give us exactly 3y minus 2. Multiplying here, this is called the distributive law, distribution from the right-hand side. So we have 2y times y giving us exactly 2y squared, and this is giving us minus 2y, because y times The 2y gives us 2y squared, and minus 2 times y gives us minus 2y. At this point, we have the following. Right, at this point, we have the following. So what we have is exactly 2y squared, and this is minus 2y minus 3y, which is exactly minus 5y plus 2 equals 0. And we are able to factor this, which means is 2y and y. And now we actually are able to see the factors of this expression. Let us think of what the factors of this are going to be. Okay, so you put a minus 2 there, 1. I'm not going to waste a lot of your time with the factorization. I know you really are able to do that one. At this point, we're able to see that y is actually 1/2, or y equals exactly 2 there. Y equals 2. Right, when we get to this point, we're able to see, therefore, that we have that x is equal to 2y minus 2, which means x equals 2, and the y is 1/2 minus 2, which means 2 times that is 1 minus 2, and this is minus 1. So we therefore have been able to achieve the results. So we got exactly those results there, and we are able to see therefore that the result is exactly minus 1 for one of the x values, wherever wherever y is 1/2, we have that our x is exactly minus 1. We continue to say whenever y is 2, our x is 2y minus 2, which is 2y is 2 minus 2, 4 minus 2, which is exactly 2. So whenever our y is 2, our x is 2. And this is the answer. This is the answer. Okay. This is a solution to this multi-test equation 1.2. Next question. Next to look at 1.3. In 1.3, now we're given that this here, an exponential equation where m and n are integers, determine the value of the sum, the value of m plus n. So we have 2 to the power m plus 1, 2 to the power m, which equals 3 to the power n plus 2 minus 3 to the power n. At this point, we break this up, we separate this, and it becomes that plus 2 to the power m equals 3 to the power n, 3 to the power 2, and 3 to the power n. Okay, at this point, we have the common factor, the highest common factor here, and it is exactly 2 to the power m, leaving us with only 2 plus 1. This is exactly 3 to the power n, which is 3 squared minus 1. Okay, so yeah, let's deal with this. So we want to find the sum of m and n. Okay, so what is 2 plus 1? It is exactly a 3. Right, so it is exactly 2 to the power m times 3 equals 3 to the power n. And we have here, this one here. 3 squared minus 1. Okay, 3 squared is 9. 9 minus 1 is 8. Like so, okay. And at this point, we have a couple of things that we need to we consider. So we have 2 to the power m times 3, which is 3 to the power n times 2 to the power 3. Okay, so m equals 3. And simultaneously, when m is 3, by comparison, because we're looking at integer solutions anyhow, so we can actually just compare when m is 3 and also when n is 1. This is certainly very, very true. So that in the end, then we have m plus n, which equals exactly a 4. Right. So obviously, we determine the value, where to find the value of m plus n, and you can see that m plus n is exactly 4 there. Next question. Right, given the arithmetic series 7, 12, 17, etc., we need to determine the value of t subscript 91, but also we need to calculate the summation of the first 91 terms of the series. Right, we have created more space for us to work on or to work with, and we have managed, therefore, to we can manage to realize that at this point, I want to do the first question. It is an arithmetic progression. So it means that if you have T2 minus T1, T2 is 12 and T1 is exactly 7, and therefore the difference is what? Is exactly a 5 there. Okay, so that gives us a common difference. But also you can check if T2, T3 minus T2, you can get it twice, but they already said it's arithmetic, so one difference is enough. But yeah, we do, but yeah, we just need to make sure the examiner is on point. So that we have the third term, 17, minus the second term, 12, and the result is a 5. Take a look at the fact that therefore our common difference is 5 there. Take note of that. So we have Tn equals a plus n minus 1 times the common difference d. Tn equals the first term, right? The first term is 7. So we have that the first term is 7 and minus 1, the common difference is a 5. Okay, so we have Tn equals 7 plus 5n minus 5, which means that Tn is 5n plus 2. Take note of that. So yeah, we have exactly that. Okay, so that is what we have. Right, at this point, we need T91, so which therefore means that T91 here is 591 plus 2. Right, and we use our calculator to do this in the exam, and we're gonna actually use our calculator here. And at this point, if you have the full that we're 5 times 91, and we're adding a 2 to that, and we can see the result is 457. Right, so we have exactly 457 is the answer there. Okay, so it's something that you need to take note of as a consequence. Okay, so we move to the next point. Right, so at the next question is question 2.1.2. Right, question 2.1.2 is a very, very important one, and we have S91. In which case, therefore, S91 is the summation here of the first 91 terms. There are a couple of ways to do this question, but we're going to use a very standard approach. We use the summation formula for the arithmetic progressions, which is exactly this one here. It's given at the back of the examination paper, where the first term is actually 7. We have already seen the common difference is a 5, in which case obviously, in this formula, our n is 91 because we want the sum of the first 91 terms, getting a 91 out of 2, twice a, which is exactly 7, 91 minus 1, the constant difference is a 5, like so. Getting S91 equals, we're going to use a calculator here to maintain what we're doing. So we write back, right? So we're going to actually bring our calculator, right? So our calculator is this one here. And what do we have? We have exactly, let's press on. We have exactly 91. Okay, with 2 times 7 plus 91 minus 1 times 5. Okay, so we close here, which is exactly 2. 111, 2. Okay, so yeah, we have 2 here, 1, 1, 1, 2, and that is the result. 2, 1, 1, 1, 2, and that is the summation. Next question, we're looking at 2.1.3. In 2.1.3, we want to calculate the value of n, for which the nth term is this one. Okay, look. We know a couple of things. Right, we already know that at this point, our Tn is a plus n minus 1 times the common difference, which means Tn equals the first term is 7 plus n minus 1, the common difference is a 5. Right, which is 7 plus 5n minus 5. Tn equals 5n plus 2. Okay, look. Okay, now, there is a specific term for which Tn is 517. So Tn is here 5n plus 2, and this is 517. 5n equals, yeah, it's 517. Okay, it's 517. So you transpose and subtract. 517 minus 2 is 515. 5n out of 5, we divide 515 out of 5. You're getting n equals, okay, so we do our division there, and this is actually 103. And that's the answer. We continue right now to do the next question, and we proceed as follows without any waste of time. Right, looking at question 2.2 as part of this question on the arithmetic progressions, let us analyze this. But now, the following information is about a quadratic number pattern. Right, if this is the quadratic number pattern, you need to show that the fifth term is actually 111. And to do this, we proceed as follows. Right, so the couple of things, obviously, that remain very, very important for us to take note of. But we actually note that we have been given this particular number. So the first term is a 3. The second term minus the first term is 9. So it means that it must be 12 here, because it can only be 12 minus 3, it's a 9. And then now the third term minus the second term. So we have the third term minus the second term must be 21. So there's a number minus the third one minus this, or in other words, you can say T3 minus T2 is 12. Even here you can do the same. Okay, so you can say T2 minus T1 is 3 equals 9, which means T2 is equal to 9 plus 3, 12. That's why this is 12. So obviously, you know that T2 is 12. You can put 12 here, getting 21. So that T3 is actually 33. It's actually a 33, so you put a 33 there, okay? So you can do these kinds of things. And then at this point, we continue with much simplicity, and we want to get the rest of this, and we are able to generate these particular sequence. Okay, now look. We can get the rest of this, but now let us find, we want to find the fifth term. So the fifth term, therefore, is in the usual way. We find the differences here. Right, so the difference here, 12 minus 3, it's a 9. 33 minus 12, it's 21. And we're going to continue and find the subsequent terms. So if this one here, obviously we know this one is always the arithmetic one. So at this point, we get a 12 here. And we expected 12 here. So, but in other words, 9 plus 12 is 21. And then we have 21 plus 12, which is actually exactly a 33. Right, and we obviously know this is still 12. And if we add actually the terms here, right, so also when you add this and that, you get 33, you add 33 and 33, you get a 66. Right, and now you continue. If this is 12, if you add 33 and 12, well, you get what? You get a 45. And now you continue like this, and you added this 33 and 33, you got the 66. You add 46, 66 and 45, and you get exactly 111, and so on. Okay. Now this is term 1, term 2, term 3, term 4, term 5, and therefore, as a consequence, we were able to see therefore that the fifth term is actually that. So thus, the fifth term is 111. Okay. And or you can say the fifth term is given by. So to get the fifth term, the couple of things that obviously we are able to do. To get the fifth term, we can see what we did. So you can take the first one, the first term, and then add 9, and then add 21, and then add 33, and then add 45. And the result is actually the fifth term. So the fifth term can be seen as 3 plus 9 plus 21 plus 33, we mean here, 33, right, plus 33. So it's 3, 9, 21, 33, and 45, and therefore the result is 111 there. So that is one way to get the fifth term, and there are a couple of other ways as well that can be used to get the fifth term, one of which is just getting the formula first. Right, let's look at the next question. In the next question, we show that the general term of the quadratic pattern is given by the following. So now at this point, what do you have? You already have seen that the first term is 3. This one is exactly a 12. Right, we've already done that. So I'm just going to repeat the pattern. So this is exactly 12, and this is 33, and this is actually 66, and this is actually exactly 111. And at this point, you have the following. So you have exactly a 9, you have 21, you have 33, and you have 45. Like so, you find the differences here. Okay, if you find the differences, right, so getting the differences here, for example, you have 12, 12, 12. Getting 2a equals 12, right? So you get 2a equals 12, and here you have 3a plus b equals 9. You have a plus b plus c equals the first term. So you always write like this, meaning now want to find the general pattern. So which means that 2a is 12. And if 2a is 12, we divide the left by 2, the right by 2, getting a is 6. There's 3a plus b equals 9, which means 3, that plus b is 9. 3 by 6 is 18 plus b is 9. And this is b equals 9 minus 18. And therefore, this is a minus 9. Okay, so which is a plus b plus c equals the first term, which means a is that plus that equals 3, which means now 6 minus 3 is a minus 6 minus 9 is a minus 3. And you have that 6 is c is equal to 6 there. Okay, now let's take a look at this and make sure you understand that. And therefore, what is the general term? So we're able to see, therefore, that the general term, which is normally an squared plus bn plus c, will therefore be given by t sub n, where a is 6. So it's going to be 6 n squared minus 9n plus 6, like so. So yeah, we therefore have been able to obtain the general term of the quadratic pattern, which is this one. Next, we actually focus on 2.2.3, and we show that the pattern is increasing for all n in the natural numbers, for all n which are elements of the natural numbers. Okay, let's look at that. So looking at the 2.2.3, we get the following. Right, so the couple of ways, obviously, to take this into account, one of which is to decide on what necessarily happens at this point. And we're able to see a couple of things. And I would like to us to always use that, okay, because to see what is happening, one way is to look at the fact that your Tn can be seen as so yeah, because your Tn is 6n squared minus 9n plus 6. Okay, so this is the general term. Okay, if this is the general term, because we're to show that it is a general term, now we take note of the fact that our n is minus b over twice a, minus the b is minus 9 over twice a, which is 6, 9 out of 12. Okay, what is 9 out of 12? What is 9 out of 12? Right, so 9 out of 12 is 3 out of 4. Okay, we always use this formula. This formula is for what you call the axis of symmetry. Right, the axis of symmetry of a parabolic function, of a quadratic function. So yeah, take note of that. And at this point, we then are able to see that n is actually 3 over 4 as the axis of symmetry. And this means that we have the minimum, and the minimum occurs at what value? Right, so right, the minimum therefore will have to occur at this, but this is not a counting number, all right, in terms of positions. Right, so in other words, because this is 0.75, so the minimum occurs at n equals 1 for this, because this kind of graph is a graph of this form that has integer values of n. And so now at this point, then you're able to see that it will have a minimum at the axis of symmetry. And okay, at the axis of symmetry, we're able to see therefore that n is exactly 3 quarters. Okay, take note of the fact that n is 3 quarters. Okay, if n is 3 quarters, what then do you think of this? We need to then realize therefore that at this point you're going to have a minimum, but now n itself is not an integer. The 3 over 4 is not an integer, so therefore the minimum will occur at the nearest of this, and therefore it's going to be at 1, 4. And in the natural numbers, we're taking the natural numbers. So, and as a consequence, then what then we're able to see is that at 1, at n equals 1, the function therefore will be therefore an increasing function there. Right, so show that the pattern is increasing for all n. So, and therefore we're able to see therefore that the function is increasing. So therefore Tn is increasing. Right? So Tn is increasing for n in the natural numbers. So Tn is increasing for n in the natural numbers. Okay? So we have exactly that there. And we continue therefore to look at the next question. Right, the next question is about our geometric progressions, and given a geometric series of this form to n terms, we want to write down the general term of the series. We look at 3.1.1, and we have made space available for us to work with. Right, so the given a geometric series, we learn at grade 11, therefore, that this is AR to the power n minus 1. Okay, take note of that. So you have AR to the power n minus 1. Look at the fact that this Tn is therefore given by the fact that the first term is 3, and therefore now T2 over T1 is 6 out of 3, which is 2. Okay, the examiner has already told us that it is geometric, so that the constant ratio is 2 to the power n minus 1. And therefore, that is the answer. So write down the general term for this series, and this is the general term for this series. It is Tn, or T sub n, equals 3 times 2 to the power n minus 1. Next question. 3.1.2, calculate the value of k such that this summation is 98,301. And now to answer this question, this is about a summation. So first things first, we need to write out this particular summation. And to write out this particular summation, we proceed as follows. So we take the general sum like so, and we have 3 over 2, and we have 2 to the power p. Okay, from p equals 1 is 3 over 2, 2 to the power 1, 3 over 2, 2 to the power 2. Okay, we're starting from 1, then we have put 1 here, we put 2 there, and we have 3 over 2, 2 to the power 3, and so on. Okay, just writing 3 is often enough. We can write more if it is necessary, and therefore we are able to realize a couple of things. What are we able to see here? For example, we're able to see that this is 2 to the power 1, which is only 2. 2 cancels, giving us a 3, plus 2 squared is a 4, divided by 2, it's 2 by 3, 6. And this one is 8. 8 divided by 2 is 4 by 3, 12. Okay, and therefore we have the pattern there. Right, so now this one is Sn, which is a open bracket, r to the power. Okay, can you use any of this? Okay, but first things first, let us get what our constant ratio is at this point. So we're gonna proceed and say T2 over T1. T2 is 6, T1 is 3, once again, which is exactly 2, meaning our R is 2. Right, of course, we okay, it is exactly the same there. Okay, it's exactly the same as that one. Okay, as the given one in the beginning. So just take note of that one. Okay, right. So which means that we have Sn equals, okay, is A, here we can use 1 minus R to the power n, and the different schools of thought, but yeah, we can use this particular formula there, but you can also use, okay, that too. I mean, it's the same thing, this. We have A, which is R to the power n minus 1, or minus 1. So these are the same formulas where R is different from 1. Meaning at this point, what do we then get here? Which is San equals A, which is R to the power n minus 1 divided by 1, R minus 1. Okay, let's use, I just like using the 1 minus R to the power n divided by 1 minus R. It gives the same answer. So these ones will always give the same answer. Right, but somebody will argue that if the constant ratio is bigger than 1, it's 2, then you need to use this one, and but yeah, it's just bureaucracy. Okay, right, so let us use this. So which means the summation. What is the summation? The summation is 98,000. So Sn is 98,301 equals the first term. The first term is 3. 1 minus the constant ratio is 2 to the power n divided by 1 minus 2. Okay, what is 1 minus 2? 1 minus 2 is exactly a minus 1. And if this is the case, and we have a minus 1, so this is 98,301, and this is a minus 1, and you divide everything, which is 2 to the power n minus 1. Okay, if it's minus 1, then 1 minus 2 is minus 1. If you divide by negative, this is going to be plus, and the 1 is going to be negative. Okay, distribute by 3. We have 98,301 equals 3 to the power, 3 times 2 to the power n. Okay, 3 times 2 to the power n. And then this is minus 3. You add this one to either side, is 98,304 equals 3 times 2 to the power n. You divide the left by 3 and this one by 3. And if you do this kind of division, you're able to get the results. Let us just use the calculator here to make sure that we're able to get the result that is wanted. So in the end, then, with 98,304 divided by 3, and this is actually 32,768. Right, so 32,768, and that is what we write down. So this is actually 32,768, and this is equal to 2 to the power n. And this is exactly 2 to the power 15, which is 2 to the power n, and therefore our n equals 15. And now at this point, we're just using this formula with n, but obviously we can be able to switch this. And as a consequence, we can see that we can then conclude that our k is actually exactly 15 there. Okay, because we used n all the way, but yeah, at this point, the sum of the of k terms. So all the terms now you're summing from p equals 1 to p equals k, and therefore the value of k itself is actually 15 there. So k equals 15. Next question. Next question. Right, now a geometric sequence and arithmetic sequence have the same first term, the common ratio. All right, so let's just look at this particular question. So you're dealing with an arithmetic and a geometric sequence. They have the same first term. So let us deal with one as an arithmetic sequence, and this one, this one be a geometric sequence. And this arithmetic sequence, they have have the same first term. Let's call it A. And now the common ratio of the geometric sequence is 1/3. Right, so, and you have that the common ratio of the geometric is 1/3. The common difference of the arithmetic is 3. So here, I'm going to put the common difference for the arithmetic is 3, and here the common ratio is 1/3. Okay, now the sum of the first, or the sum of 22 terms of the arithmetic sequence is 734, more than the sum to infinity of the geometric sequence. Okay, let us look at these here exactly and look at what we need to do. So, right, we are finding the sum of 22 terms. So now what we need to do, you need to realize that Sn is the same as what? Is n over 2 twice a plus n minus 1 times the common difference. So what we then have is therefore that you have Sn equals, right, so the n is the same as what? These are 22 terms out of 2, which is twice a, which is exactly a there. And this is the sum of 22 terms. Let's replace this one by 22 as well. Right, n is replaced by 22, so that here you have 22 minus 1. You can just put it 21. We already have the common difference, which is 3. Like so. Right, getting S22 is equal to, right, so this is exactly the same as 11 to a plus, this is 21, 21 by 3, and 21 by 3 is actually 63. Right, getting S22 equals. So we then have here exactly 11 times 2 is 22a plus 693. 693 is 11 times 63. Okay, now there's something extra. And the extra thing is that now what we have here is that the sum of 22 terms of the arithmetic sequence is 734, more than the sum to infinity. Okay, we need to find the sum to infinity, which is 1 divided by 1 minus r. And therefore, you have the sum to infinity. The first term is the same, and this is 1 minus the common ratio is 1/3. Okay, let's find the sum to infinity, which is actually the same as 3a out of 2. Okay, we have that. Right, so now, if the sum, okay, the sum of 22 terms of the arithmetic sequence is 734 more than the sum to infinity. So we will say then the sum, if you compare the sum of 22 terms of the arithmetic sequence is 734 more than the sum to infinity. So this one is bigger. So we're comparing with the sum to, if this one is bigger, therefore you need to add the 734 on the smaller side. And then, okay, this is good. And therefore we have the following thing. Okay, now the S22, we know that is actually 22A plus 1386. And this is actually exactly 3A out of 2 plus 734. 734. And therefore, what we're then getting here is that if you subtract every single bit of thing, multiply through by 2, because of the 2 here, multiply through by 2. 2 times 22 is 44A plus. Okay, I need to change this one here. Okay, note that S22 is 22A, right? It is 22A plus 693. Plus 693, and then we have S infinity, which is exactly this plus that. So yeah, multiply through by 2, which is 2 times 22, which is 44A. And then you have 2 times 693, which is 1386. This is actually exactly 3A plus. And then now you multiply this 7 by 2, 734 by 2, you get 1468. 44A minus 3A is actually 41A. 82. Okay. So, which is 41A, which is exactly 41A, which is 82. You divide by 41, you divide by 41. And this means that A is equal to 2. Okay, but because we have to calculate the value of the first term, we can see that the first term is 2. And we've solved this problem. And we're done. Next question. Right. So, yeah. Sketched below is the graph of the exponential function. A and B are respectively the y and x-intercepts of f. Write down the equation of the asymptote of f. Right, so the asymptote is what exactly sits over here, and we can see therefore that the asymptote is actually minus 4 there. Right, so next question. In the next question, we look at 4.2 and we want to determine the coordinates of B. B is this one here, which is the x-intercept. So now in 4.2, we want to find the x-intercept. How do we find x-intercept? We let y be 0 in the function, which means 2 to the x minus 4 equals 0, like so. We're able to compute exactly the value of x, which means 2 to the power x is 4, 2 to the power x is 2 to the 2, which means that x is 2. Okay, if x is 2 but y is 0, meaning the coordinates of B therefore are x is 2 and y is 0. And we found the coordinates of B, 2 and 0. Next question. Right, in 4.3, we want to determine the equation of K, a straight line passing through A and B. There's a straight line that passes through A and B, and we want to determine the equation of this straight line. Okay, we've already seen that the coordinates here are 2 and 0, but we do not know the coordinates of A yet. But we're able to see that A is clearly the y-intercept. So we must find the coordinates of A, the y-intercept. So to get the y-intercept of F, we let x be 0 in the equation. So we have f of 0 here in the equation, which is 2 to the power 0 minus 4. 2 to the power 0 is actually 1 minus 4, giving us actually a minus 3. At this point, we're able to see that A has the coordinates x is 0 and y minus 3. So x is 0 and y minus 3. Those are the coordinates of the point A. Okay, right. If these are the coordinates of the point A, 0 minus 3. Okay, we want to find the average gradient. So which means that the average gradient. The average gradient is m, which is change in y, change in x. which is y2 minus y1 over x2 minus x1, x1, y1, x2, y2. y2 is 0 minus, and x2 is 2 minus 0, which is 3 over 2. Okay, so you have this, 3 over 2. Right, so at this point, we are able to determine the equation of k. Right, this is the slope, and so this line here passes through, so we use the word through in the exam. This is a past exam question, so it is through A with the coordinates 0 and minus 3. So we use y minus y1 equals m into x minus x1. Y minus y1, x1, y1, which means that y1 is minus 3, m is 3 over 2 into x minus 0. Y is the 3 over 2, x, and this is plus 3, which is minus 3. Right, and to find the equation then is y equals 3 over 2x minus 3. And this is actually the equation of the straight line. That the examiner wants. We're done. Next question. Right, in the next question, we want to calculate the vertical distance between K and F. Right, at x equal to 1. Remember that we found this line, which is K of x. And K of x, actually, we know that it had the equation 3x minus 3 over 2x minus 3. And we want to find the vertical distance at x equal to 1. Okay, we already know the coordinates of B. Right, the coordinates of B are 2 and 0. And we already know the coordinates of A are 0 and minus 3. And now how do you find, so x equal to 1 is somewhere here. So if x equals 1, that is between 0 and 2. Right, so at this point, if you want to find the vertical distance, so we need to evaluate each function at the point. So we're going to find k at 1. If this is the function, so we're going to have 3 over 2 times 1 minus 3, which is 3 over 2 minus 3. And this is actually minus 3 over 2. We need to evaluate the function f at 1, which is exactly the same thing as the 2 to the power x minus 4. Okay, that is the function f of x, so that f at 1 is 2 to the power 1 minus 4, which is actually minus 2. Which is actually a minus 2, yeah? So what is the vertical distance? And therefore, we're able to continue and see that the vertical distance is actually the same as, okay, if we have these two numbers, we want to find the distance between these two numbers. You take the largest number, which is minus 3 over 2, minus the smallest one, which is minus 2. At this pointer, this is 1/2 units. 1/2 units, so which means that the vertical distance, right, the vertical distance is actually 1/2 units, and you can write it as 0.5 units. Can you use a decimal comma, 0.5 units? Okay, so we're done there. And we continue now to look at the next question. The next question is actually question 4.5. Write down the equation of G if it is given that this is the case. Right, so to write down the equation of G, we have G of x equals exactly f of x plus 4, which means G of x equals the x is 2 to the power x minus 4 plus 4, which means that G of x is 2 to the power x. So, and now this is the equation. So the equation is 2 to the power x, but you need to take a note of the fact that this function is between those two. So it is true here, but x is an element of the interval minus 2 close and 4 open, because there's an open circle there. So that is the function g. So if the examiner would ask you to write down the equation, you would say g of x equals 2 to the power x, and x is an element of the interval minus 2 to 4, like so. Next point, 4.6. Write down the domain of G inverse. Right, the domain of G inverse is as follows. Right, now the couple of things obviously to consider. So we must therefore first determine the range of G. Right, so now if you have G, we are able to see that G itself, G of X, we saw that G of X is 2 to the power X when the function itself is from -2 to 4, like so. And so now what is the range? Let us find the range. So the range of G. Right, so we find out the range of G, and the range of G is Y, which is an element of. Right, so the range of G therefore becomes Y, which is an element of the following. So in the end, then a Y will actually be when X is -2. So you'll be able to see that Y is 2 minus 2. Yeah, let's use G. So our G, therefore, it's going to be exactly like G at -2, which is 2 to the -2. And G at -2 is going to be 1 over 2 squared, which is 1 over 4. So the range is going to be 1 over 4 here. And then it's going to rise up to whenever there is X equals 4 there, which means G at 4 is 2 to the power 4, which is 16. When X is 4, then you have 16. So this is actually from 1/4 to 16 there. But 16 is actually the open end. 16 is the open end. 16 is the open end, like so. What is the now? Okay. At this point, we are interested then in finding the domain of the G inverse. So, which means that we have the domain of G inverse. Okay. So to find the domain of G inverse, we must first find the range of G. And therefore, the domain of G inverse is given by X, which is an element of, so you put X here wherever there is Y, and we have 1/4 and that. So in other words, so the range of G becomes the domain of G inverse and vice versa. If you don't want to write your answer like this, you can also say that your X therefore lies between 1/4 and 16, like this. Next question. 4.7, write down the equation of G inverse in that form. Right, so what is the equation of G inverse? Right, so the couple of things that we need to take note of, that our G of X is 2 to the power X when X is an element of the interval. From what? Okay, so we know that X is actually an element of the interval from -2 here to 4, like so. Okay, but yeah, the -2 is included. The -2 is included. The -2 is included. So that now, this is exactly 2 to the power X, which is G, and then now to find G inverse, if this is the equation of G, and G is Y equals 2 to the power X, then the inverse is going to be wherever there is Y, you put X, and wherever there is X, you put a Y. And then now we have the G inverse of X, and G inverse of X becomes what? Okay, you can write it as an equation. Okay, at this point, if you have this, then you can solve for Y, which means it is the log of X base 2 equals Y. So you can just put the log here, and the 2 becomes the base. And this new Y is, so it is the G inverse, which is the log of X base 2. Okay, what is the equation of G inverse, which means G inverse of X is the log of X base 2, and X is an element of the interval, which is 1 over 4, 16. 1 over 4, 16. 1 over 4, 16. Okay, so we continue. We continue. We continue as follows. Right. Next point. Right. In the next question now, we're going to look at this particular graph here. The graphs of f of x equals minus 1/2, open bracket, x minus 1 squared plus 8 equals g of x equals d of x, drawn below. A point of intersection of f and g is B, the turning point of f. The graph f has x-intercepts at -3 and 0 and 5 and 0, and a y-intercept at C. C can be seen there. And now write down the coordinates of the turning point. Turning point is seen here. So the coordinates of the turning point are clearly 1 and 8. You can really read them off from the graph. Next question. Need to now calculate the coordinates of C. And now C, it's the y-intercept. And so now you say the y-intercept. So the way you do the y-intercept, you let x be naught in f. So f is that one, and therefore f of naught is 0 minus 1 squared plus 8. And therefore the result is actually the same as what? It is exactly the same as the following. So this is exactly the same as minus 1/2 plus 8, and the answer is 7 and 1/2. And which means that the coordinate of C, goodness me, when x is 0, y is 7 and 1/2. If you don't want to say 7 and 1/2, you can say that obviously 7 times 2 is 14 plus 1 is actually 15 out of 2. So you can write down the coordinates of C as shown there. Next question. Right, the next question is about calculating the value of D, and D is part of the hyperbola function. But now look at the hyperbola function. Choose a point through which this function passes. So this this hyperbola function passes through a given point. The question is, what point does this pass through? Whose coordinates we know very, very precisely. Right, so we're able to see at this pointer that it passes through, for instance, now there's a point of intersection, which is the point B, and we actually know that it is the turning point, so B would have the coordinates 1 and 8. Okay, so right at this pointer, in other words, it passes through. It passes through B. It passes through B with the coordinates 1 and 8. And if this is x and that is y, which means g of x is d over x. And then y is 8 and x is 1, which means d is 8. Okay, so at this point, we have that d is 8. To calculate the value of d, we're able to see, therefore, that d equals 8. D is 8. Next question. Write down the range of G. Write down the range of G. Okay, let's look at this. Right, the range of G, take note of the fact that G itself is this function, and its range will be nothing other than what? So the range of G is going to be, because it's this function, G of x, which is 8 over x. What is the range? The range is going to have y not 0, but y is an element of R. Or you can start by saying y is an element of R, but y is not 0. Yeah, y is an element of R, y is not 0. That becomes the range there. Y is an element of R, but y is not 0 is actually what we have. Next question. Right, so we continue with the next question. The next question is 5.5. For which values of x will the product of the two functions be negative? So we want this function such that there is a negative times a positive, and the result is negative, or we have a positive times a negative, which is negative. Okay. Negative, positive. Okay, then negative. Negative. positive there. Okay, so now we want to for each of x is the product of the two functions negative. So we are looking at where the functions have opposite signs. Here they're both negative. This one here is positive and this one is negative. Okay, so and you can see that it happens up to this point. So you can see that it happens between -3 and 0. Or, okay, there's another part here where one of the functions is negative and the other one is positive. So it also happens when x is bigger or equal to 5, which means therefore that x is an element of the interval -3, 0 union 5 up to infinity. You can write your answer in any of those forms above. In the next question, we want to calculate the values of k so that these ones will not intersect. Okay, let's look at that one. So calculate the values of k so that h, which has the equation -2x plus k, will not intersect the graph of g. Just look at the function h. Now, the function h is given as follows. H of x is -2x plus k. And the function g of x, so we already know that it is 8 over x. Right, so we want to calculate the values of k so that these will not intersect. Right, and to do that, we proceed as follows. So we equate these two functions and find -2x plus k, which is 8 over x. Right, so if we have this, we cross multiply so that we have -2x squared plus kx minus 8 equals 0. That's the equation we get, from which we're able to get our discriminant, which is b squared minus 4ac. Right, our b is k squared minus 4, our a is -2, and our c is -8, and this is k squared minus 64. And calculate the values of k so that these will not intersect, and therefore the discriminant is less than 0. And therefore, what are the critical values? What are the critical values? The critical values of this would actually be obtained when k squared minus 64 equals 0, which means k squared is 64, and that means k squared is actually the square root here plus or minus the square root of 64, which means k is plus or minus 8, because the square root of 64 is 8. We're interested in parts where this discriminant is actually obviously a negative, and yeah. Can do this, can do it like this. Yeah, when this discriminant is negative, so we look at this graph here. It might look different to many learners there at this point, but we can obviously it's plus or minus 8, so some learners would find it easier to do it the way we did the first question. So it might be that we can just say k minus 8, k plus 8 here is less than 0, and then get the critical values. Okay, right, and then get the critical values like we did the first question. I feel that that is going to be much easier to follow, so that doesn't look very different. So you have the critical values. What are the critical values? K equals 8, k equals -8. Okay, so you have -8, 8, and this is actually k. Okay, now look, when this is negative, it means a couple of things. It is negative, it means therefore that it is negative. We're looking at the part where it is below, and we're looking at this part here. And it is negative then between -8, which is less than k, less than 8. Right, so we have exactly that part there. Next question. The next question is actually the question. So we have calculated in 5.6 the values of k so that these will not intersect the graph of g. Let's look at 5.7. 5.7, h is a tangent to g at r, a point in the first quadrant. Calculate t such that this is the case, such that this intersects g at r. So let us look at this question. Okay, so we are looking at the fact that h is a tangent to the graph of G. So if h, now we know that h in the first question is minus 2x plus k. So that obviously at this point we have already got the k, and it's minus 2x plus 8, which means that it's minus 2x plus 8, which is equal to 8 over x. And if we cross multiply, which is minus 2x squared plus 8x equals 8. And this is actually 2x squared minus 8x plus 8 equals 0. Which means you have x squared minus 4x plus 4 equals 0. X minus 2 all squared equals 0. X is 2 out of this. X is 2 or x is 2. Teach yourself to write all the solutions. These are equal roots of this quadratic. Right, so obviously we're doing 5.7. So if it's a tangent, then you can equate them so that now the function h, because h is a tangent to graph of, is a tangent to G. Right, so this obviously has a negative slope and it becomes a tangent to the graph of G. So it sort of runs the down slope there, depending on the actual position, but it touches the either here or there. Something of that sort. Okay, so at this point, these are the two values. So we are then saying a point of in the first quadrant. Okay, if it's a point in the first quadrant, then you need to remove this part here, so that it is a tangent here to the point, a point in the first quadrant. This is the first quadrant, the second, the third, and the fourth quadrant. Okay, good. Now we continue to solve this problem, but now we are then saying calculate t such that this intersects the graph, intersects G at R. So if y, which is f of x plus t, intersects G, it means something. It means something. It means, therefore, at this pointer, you can find f at 2. And f at 2 is the same as what? Right. We know the function f, and it is the quadratic. And we need to just write it down again to make sure that we write very correct answers here. And we will remember that the function f, we'll just write it down quickly. We'll remember that the function f of x is actually equal to minus 1/2 x minus 1 squared plus 8. Okay, so which is exactly equal to f of x, which is equal to this. So that in the end, then we have f of 2, which is minus half, which is 2 minus 1 squared plus 8. Right, and it is easy to see that this is 15 over 2. It was done before. It was done in the previous question. We saw that it is 15 over 2, or it is 7 1/2, like that. Okay. Now, the function h at 2, which is h here. So this is going to be minus 2, and then times 2 plus 8. Okay, which is 8 minus 4 is 4. Okay, now this is what we have. So calculate t such that this is the case, such that this intersects G, right? So if this intersects G, it then means that this here can be actually seen as follows. It can be seen as h of x for a y and y, but it intersects such that this intersects G, so it must be h, because h and G intersect. Right, or obviously, there are a couple of ways to do that. Or you can also use G. Okay, using H, if H equals exactly f of x plus t. H at 2, so you're going to have H at 2, which is f at 2 plus t. What is H at 2? It's 4, which is 15 over 2 plus t. Okay? So we have 4 minus 15 over 2, which is exactly minus 7 out of 2. Minus 7 out of 2. Right, minus 7 out of 2. So yeah, that's what we have. So we have exactly this result. Okay, yeah, t is minus 7 out of 2. So yeah, we're to actually calculate t such that this intersects g. So you can use here either g or any of the functions there. Okay, we continue. Either h or g, but we chose h and it works as well. Okay, in the same way. So you continue. Next question. The next question is on mathematics of finance. Patrick is a very smart guy and he deposited an amount of money into a bank account. Let's do finance together. Right, doing finance, we proceed as follows. Now, Patrick deposited an amount of 18,500 into an account, earning 8% interest per annum, compounded monthly. After 6 months, his balance was 19,319 rand and 48 cents. Right, obviously, you can see that from 18,000 to 19,000, it's actually an increase. So we're going to use the appreciation formula, which is exactly 1 plus I to the power n. Which means that you have 19,319,48, which equals 18,500. And then this is exactly 1 plus. Okay, because it's 8% interest, then what you're going to do, this is compounded monthly. So it's 12 times 100. And it is after 6 months, his balance was this. So n is actually 6 months there. And now let us continue to solve this particular question. So you divide by 18,500. So this is 19,319,48. You divide by 18,500. And this is actually exactly what we have, which is 1 plus r over 1,200 to the 6th power. And what we then do is we take here the 6th root, and we take here the 6th root. Okay, let's continue here. So now at this point, what we have is 1 plus r over 1,200, and we're going to use our calculator here. Right, now doing division, which I've done, if you divide this here is 1,04429 like this. Okay, now you need to solve for r so that r is exactly the 6th root. 1,04429 minus 1 times 1,200. Okay, let's use the calculator. So that in the end, then our R is actually 8.7%. I'm not going to waste a lot of your time there with the calculator, but we want to find the value of R. And in this point, because it was R% interest per annum, and we're able to see, therefore, that our percentage is 8.7%. Next question, we want to calculate the effective interest. So to calculate the effective interest, we have the following. Right, to calculate the effective interest, we use the following formula that we'll learn at grade 11 for the effective interest. So we know that 1 plus I is 1 plus I effective equals 1 plus I nominal, right? And we divide by, we do some divisions. We remember that one. So let me just write down the formula. So here we write, yeah, We divide by m here. On this one, we raise it to the power m, and this becomes what you call the nominal rate. Okay, let's continue quickly without wasting much time. So this one, obviously, we want to calculate the effective interest rate at this point. So to calculate the effective interest rate, then we're going to say exactly I over 100, which is equal to 1 plus the nominal rate, that is what we got in the previous question, is 8,7. Because it's per month, then we say 12 times 100, we raise these to 12. Okay, want to calculate the effective rate. So this they can ask you in the exam. Please take note of it because it's very, very important. So that I is exactly 1 plus 8,7 divided by 12 to the 12, you minus 1. And then this 100 is going to sit here. Right, so at the point you use your calculator to do this, and you are able to get the result that is needed. So you're going to be able to see that I is 9,06%. So that is what you are getting here. So I is 9,06%, and that is the rate that is wanted over there. Just take note of that. And we continue to explore. And at this point, the common tendency is to write the following. So because we know that I of 100 is R, so yeah, the best is to say R is 9,06%, where you view these as an R. As R, so it becomes exactly R equals 9,06%. So you can write exactly in that sense. Right, so meaning even at this point, if needs be, you can write this one as exactly I over 100, and you just subtract the 1 there. Right, and if you subtract the 1, you can leave it like that. So that now when you have I over 100, you can write it in that manner exactly, and you can get your result. Let's just use our calculator here. I need to give a very clear and very concise assertion on this one. Right, so at this point, for instance, if you are to have open bracket 1 plus, and then we have 8.7 divided by 1,200, and you close here, and then you raise it to exactly 12, and you subtract 1. Right, so let's see what we're getting. So we're getting exactly that result there. And if you're getting that result there, it means therefore you will have that if you divide, it is 0,0906, 0.0906. Okay, let's just write that one. Right, so we have seen therefore that, okay, which means that R over 100 is 0,0906. Okay, now if you, okay, it's an I here. It's an I here. Put I here like this. And then if you cross multiply, right, so yeah. If you cross multiply, what then do you get at this point? Okay, and obviously at this point, you can cross multiply these, and cross multiply, then it becomes 1, 2, which means it's 9,06%. You can write it like that, and yeah, it's fine with the I. So you can write that I equals that, but yeah, it can also be written as the 9. Some people use the R notation instead of the I, so you can write that R is as a consequence that. So in the event that Somebody can call this whole thing R, etc. Okay, next. With Kuda bought a laptop for 10,000 on 31st of January 2019. He will replace it with a new one in 5 years' time on 31 January 2024. It's actually in 5 years' time. The value of the old laptop depreciates annually at a rate of 20% per annum, according to the straight line method. After how many years would the laptop have a value of 0 Rand? Okay, it depreciates according to the straight line method. The straight line method, we know very well in 6.2.1 is A equals P open bracket 1 minus IN. So if this is P into 1 minus IN, and this is actually the same as, okay. So we are saying that after how many years will the value of the laptop be 0 Rand? When we know very well that it was purchased at 10,000. Purchased at 10,000, 1 minus. Right, the rate of interest is 20%, so 20% divided by 100 to get 0.2, and you have the N. Okay, like so. And you want to solve, so this one is 0 equals 10,000 minus. Okay, so at this point, if this one is 1 over 5, okay. Okay, yeah, if it is 1 over 5. So it is actually 10,000. And you multiply by 0.2. Okay, it's exactly 2,000. And then now you have 2,000 and is 10,000, which is actually 2,000 and is 10,000. You divide here by 2,000. Divide here by 2,000, meaning N is actually 5. Okay, so N is 5. Right, so the value of the old laptop depreciates annually at a rate of 20% per annum according to the straight line method. After how many years will the laptop have a value of 0 Rand? So it will exactly be N equals 5 years. So it's actually after 5 years that it will have a value of 0. So we continue. We continue. Right, we continue. Right, good. We continue, exactly. Next question, 6.2.2. Right, so in 6.2.2, Kuda will buy a laptop that costs 20,000 Rand. In order to cover the cost price, he made his first monthly deposit into a savings account on 28 February 2019. He will make his 60th monthly deposit on the 31st of January 2024. The savings account pays interest at 8.7% per annum compounded monthly. Calculate Kuda's monthly deposit into the savings account in 6.2.2. Now, there's something we need to take note of here, that Kuda will buy a laptop that costs exactly this amount. Okay, so because Kuda will, in order to cover the cost, he made his first monthly payment, monthly deposit into savings account, and he's saving the money. So this one is going to be in the future, which means that you're going to use the future value formula, and the future value formula is X equals 1 plus I to the power N minus 1 over I. Okay, we're dealing with the future value. And therefore, this means that in the future, he wants to have the money of the value 20,000 X. Okay, so because we want to calculate Kuda's monthly deposit, we want to find X, which is the monthly deposit, right? So, which is 1 plus. So the rate is 8.7 divided by, okay, remember it's monthly this, so it's 1,200. 12 times 100. And then you raise it to, remember that you will replace it with a new laptop in 5 years' time. So 5 years will be 5 times 12, like 60, minus 1. And this is actually divided by 8, which is divided by I, which is 8,7 divided by 1200. Okay, yeah, let's put 1200 here. Okay, yeah. 1200. Okay, so in the end, you cross multiply. This one times this and you divide everything. And if you do that using a calculator, it becomes exactly 267 Rand and 26 cents. So at this point, you were able to see that Kuda's monthly deposit into his savings account is going to be 267 Rand and 26 cents. Okay, you can write it like that, or you can write it like X equals exactly 267 Rand and 26 cents, like so. Okay, that's something that you can, as a matter of fact, do, so take note of that. So it's this or that. Okay, let's look at the next point. Right, so Tino wins a jackpot of 1.6 million. He invests all his winnings in a fund that earns interest of 11.2% per annum compounded monthly. He withdraws 20,000 from the fund at the end of each month. His first withdrawal is exactly 1 month after his initial investment. Okay, how many withdrawals of 20,000 will Tino be able to make from this fund? Let's look at these. Right, so now there is something that obviously we need to consider about Tino, and it is the following thing. It is the fact that Tino himself has what, so we're going to use the present value formula because winnings are, it's money that is available right now. Okay, this is about what we call annuities. So these are regular payments. So which means it is exactly 1 plus I to the power minus n, you divide by I. Okay, now we understand that Tino wins a jackpot of 1.6 million. Right, so it's 1.6 million. It is 1.6 million. Right, 1.6 million. And he withdraws, you put the withdrawals here, he withdraws 20,000. 1 minus 1 plus. Okay, it's 11.2% compounded monthly, which means that you divide by 100 here. Right, so you can put here 11,2 1200. Right, and then it is raised to the power n. So yeah, want to know how many withdrawals? So we're dealing with monthly stuff. So dealing with monthly stuff, please keep this one as minus n at the top here. Don't multiply these by 12. And so you divide everything by the 11,2, and we have 1200 there because it's monthly. Okay, but you have the 100, you always divide the I by 100. So now in the end, you multiply everything. And if you continue with this, so you divide 20,000, you divide this by 20,000, you cross multiply by this, it becomes exactly 56 divided by 75, which is 1 minus, okay, 1 plus 0,112 divided by 12. Okay, so that in the end, then what we then have is 1 plus 0,112 divided by 12 to the power minus n, and we have 1 minus this multiplied by negative, and this is going to be 19 out of 75. No matter what you do, it's going to be this. You can take this to the other side, and then 1 minus that. If you transpose, you get exactly that. Using a calculator, we're able to see the 4. That is a calculator. You can use a calculator with ease, meaning our minus n is the log of the base. Okay, the log of 19 out of 75. The base is 1 plus 0,112 divided by 12. Okay, so we have exactly that. Okay, we have exactly that. So this is exactly 19, and then it is 75. Okay, use a calculator, which is minus n, which is minus 147,80. Using a calculator here, you get this. And now, if you divide by the negative, you get that n is 147,80. So, and that means that Tino, right, Tino will make 147 withdrawals. We'll make 147 withdrawals of 20,000. Tino will make 47 withdrawals of 20,000. Okay, so we are using what we call the present value. We're using what we call the present value annuity, present value annuity formula. Present value annuity formula. Right, next question. Right, you need to determine f prime of x from first principles. Now we're discussing first principles of calculus. And now to find the first principles of calculus, we need to know the following formula. F prime of x is the limit as h tends to 0 of f of x plus h minus f of x. You divide everything by h. This is calculus. This prime means a derivative. So that you have the limit as h tends to 0 of minus 4 of x plus h. You square this minus that squared over h. This is the limit as h tends to 0 of minus 4. You square this, which is x squared plus 2xh plus h squared plus 4x squared. You divide everything by h, like so. Right. So we continue. Right, which is then the limit as h tends to 0, which is minus 4x squared minus 8xh minus 4h squared. Right, so this is minus 4h squared plus 4x squared. We divide by h. We divide by h. Like that. So we continue. We continue. Right, we continue. Right. Right, you continue. Just hang in there. Right, so right. Right, so we continue. Right, so the minus 4h squared x squared cancels out, giving us the limit as h tends to 0, and this is minus 8xh minus 4h squared. You divide by h. Okay, let us continue. Which means f prime of x is the limit as h approaches 0, you have exactly h. You can take out h as a common factor, or right, yeah, h is enough. And you have minus 8x minus 4h. Divide by h. H cancels, so that you have f prime of x, which is the limit as h approaches 0 of minus 8x minus 4h. As h tends to 0, this is f primed minus 8x minus 4 times 0, which means f primed is minus 8x. Okay, take note of that. Okay, yeah, that is the first principles result. That is the first principles result. So that is what we have there. Okay. Right. So, I mean, there are a couple of things that you consider. Now, okay, determine f prime of x if this is the case. Okay, now here we're going to use the rules of differentiation. Right, so using the rules of differentiation, we have the following. Right, so if this is f, then f primed of x, we're looking at 7.2.1 is going to be 2 times 3. You bring down the 3x and you subtract a 1. This one is to the power 1 since there's no power, so that you have 3 times 1 to the power 1 minus 1. This is called the derivative. Okay, 2 times 3 is 6. 3 minus 1 is 2. You always subtract 1. This is minus 3, and this is x to the power 0. F primed of x is 6x squared minus 3. 6x squared minus 3. And that is exactly the answer. That is exactly the answer to the question. So we proceed now to solve the next problem. The next problem is 7.2.2. You have this derivative. So, which means that you have d sub x, which is exactly this. But now if it is actually times the cube root of x squared plus 2x to the minus 5. Okay, this is also the derivative, different notation. This is the prime is for a derivative, but you can also have the d subscript x. 7 times x, therefore it is 2 over 3 plus 2x to the minus 5. And we have that. So now it is 7, 2 over 3, and then you subtract 1. If you subtract 1, so you have 2 over 3 minus 1. Plus 2, you bring down the minus 5 and you subtract 1. Meaning 7 by 2 is actually 14 over 3x. Okay, subtract 1 here, which is minus 1 over 3 minus 10x to the minus 6. Like that. And therefore, now it is standard practice to write your answers with positive exponents always, which means that you have 14 over 3 times 1 over x to the power 1/3 minus 10 over x to the 6th power. So that becomes the result. That becomes the result. So we have solved 7.2.2. Let us look at 7.3. For which values of x will the tangent to f of x have a positive gradient? Okay, so let's look at that. So now, if this is to have a positive gradient, we must find the gradient, and the gradient is the derivative. So we're going to find f primed. So f primed of x is the derivative of this, which is minus 2. You bring down the 3 and you subtract 1 from the top. A times 1, 1 minus 1. F prime minus 2 times 3, which is minus 6x to the 2. Right. And the 4 plus a to the 0. F primed of x is minus 6x squared plus 8 times x to the power 0 is x to the power 0 is a 1. Okay, but now we are saying I have a positive gradient, so the gradient must be positive. So positive means bigger than 0, which means minus 6x squared, 8 is positive, bigger than 0. Okay. Which means that you here, x squared is bigger than minus 8. So if this is true, then you can divide by minus 6. Right, if you divide by minus 6, then inequality changes direction. It changes direction. It was greater than becomes less than, giving us x squared is less than 4 out of 3. part of 3. Okay, and at this pointer, we can be able to get the factors with ease if we wish. Okay, if you have x squared minus 4 over 3 is negative, which means x is 2 out of the square root of 3. X plus 2 out of the square root of 3 is less than 0. So you have the critical values. Hello? Okay. The critical values are 2 over the square root of 3 or minus 2 over the square root of 3. Okay, if this is the case, we look at the fact that this is going to have the minimum vertex, but if this is negative, you're going to be considering the part that is below like this. Okay, when this is x, and this one is a minus 2 over the square root of 3, and this is 2 over the square root of 3. Okay, so yeah, that's what we have. Okay, but if this is the region that is below the x-axis, it means therefore we are where it's negative, therefore we must restrict ourselves. So which means that with minus 2 over the square root of 3 is less than x, less than 2 out of the square root of 3. So it therefore gives us the answer to this to say for which values of x will the tangent have a positive gradient. It has a positive gradient when x lies between those values there. Next question. Right. That was question 7. We'll look at question 8. Question 8 is this long one. We shall just go through it with much simplicity and ease. Determine the coordinates of the turning points of f. Okay, now to find the coordinates of the turning point, we must find the derivative of the function. So which means that we have f of x, which is actually minus x cubed plus 6x squared minus 9x plus 4. Let's find the derivative. Minus 3x squared plus 12x minus 9. Okay, at the turning points, so equal to 0 at turning points. Right, and now we divide through by negative here, by negative 3, giving us x squared minus 4x plus 3 equals 0, which means that x is minus 3, x is minus 1 equals 0, which means x is 3 or x is 1. Okay, now if this is the case, then we found the values of x. So we're going to find simultaneously f at 3. So f at 3 now, you put here minus, you put at 3, you cube plus 6, 3 squared minus 9, 3 plus 4. And f at 3 then is equal to 4. F at 1 is minus 1 cubed plus 6, 1 squared minus 9, 1 plus 4. So that f at 1 equals what? Equals 0. Okay, let's look at the turning points. Right, so this means therefore that the turning points are, right, the turning points will therefore be when x is 3, y is 4. Simultaneously, when x is 1, y is 0. Okay, so the coordinates of the turning points are 3 and 4 together with 1 and 0. Those are the coordinates of the turning points. Okay, let's get the next point. 8.2. Draw a sketch graph of f, clear label all the intercepts with the axis and any turning points. Right, so let us draw a neat sketch graph of the function. So to draw a neat sketch graph of the function, we proceed as follows. This is our y and this is our x. The x-intercepts are clear, so the x-intercepts occur when x equals 1. When you equate these to 0, you can see that x is 1, x here is 4. So it's going to be at 1 and 4. Okay, those will be the x-intercepts. And then because this function has a negative here, there are a couple of ways to realize that the shape is going to be such that it's going to have a maximum, and then you extend it like this. So, which means therefore the function is going to have its y-intercept at 4, and it's going to have its y-intercept at 4. The shape is going to be like this. It's going to go up like this and, okay, cut through 4. Okay, look at this. It's going to cut through 4, like so. Take note of the fact that, okay, this one is the function f, and it has the turning point at 3, 4, but there's another turning point we saw at exactly 1 and 0. This is the graph of the function, whose equation is f of x is equal to minus x cubed plus 6x squared minus 9x plus 4. We look at the next question, 8.3. Use the graph to determine the values of k for which these will have 3 real and unequal roots. Right, so if you look at the fact that you have already seen the graph, and the graph is actually having something of this sort at 1 and 4. Right, and also this is the y-intercept. But now we are actually interested in analyzing that part of the graph, and we are then saying here, this is the x-axis. So that at this pointer, you have that you're going to cut through y equals k. And now users got to determine the values of k for which these will have 3 real and unequal roots. So if you have here 3 real and unequal roots, what then does this mean? Right, so for instance, here, this is a root, a root, a root. A root is a point of intersection. There's an x value there, which is called the root at the point of intersection. So 1, 2, 3, and these roots are all unequal points with unequal x values. That's what we mean, right? So, but now there are 2 restrictions. So we can restrict between the turning point here, which we saw this one at 3 and 4. Which means at this pointer, we know that our y is 4. So yeah, so it is sort of a 4 there. So the 4 is obviously here we can see that. Okay, so let's see that. So our y is 4. And then, okay, there's this one here, which means a y is 0. Okay, so that at this point we restrict ourselves between this. So it means therefore that we want to find a value of k. So k can only be between 0 and 4. K is between 0 and 4. If we don't want to say that, you can say k is an element of the interval from 0 to 4. But let's look at 8.4. Okay, if you look at the line, g of x equals ax plus b is the tangent to f at the point of inflection of f, determine the equation of g. Okay, next question, that one. So, yeah, this line is a tangent to f at the point of inflection. If this one is a tangent to f, it means, therefore, at the point of inflection, there are a couple of things that you need to take into account. And if this is the case, determine the equation of the line. So would actually consider the function, which is exactly minus x cubed plus 6x squared minus 9x plus 4. Okay, I can see the time, Tando. I'm able to see the time, but yeah, I'm trying to finish the questions, which is minus 3x squared plus 12x minus 9. I've prepared a lot of questions. All right, so this one is the derivative, which is the prime. And then now, obviously, there's something called a point of inflection, which is at the second derivative. Right, so if you find the derivative again, you multiply 2 times minus 3, which is minus 6x. 2 minus 1, it's a 1. The derivative of x, we saw that it becomes x to the 0, which is only a 1. right? And obviously at the point of inflection, this means x is minus 12 over minus 6, and this is 2. Okay. So because this line is a tangent to f at the point of inflection of f, determine the equation of g. Okay, so the maximum is actually at x equals 2 and y equals 2. The maximum is at x equals 2. Okay. The maximum is at x equals 2. But now, at x equals 2, y is 2, because of the fact that if you put 2 here in the place of x, you have 2 cubed plus 6 times 2 squared minus 9 times 2 plus 4. Right, you're able to see that the result is 2 here. You can always check that this is actually exactly minus 8. And minus 8 minus 18. So if this is minus 8, minus 18 is minus 26. Minus 26, and this one is 24, which is actually 24 minus 26, which is minus 2. Minus 2 plus 4, which is exactly 2. That's why the maximum is at this particular point there. Okay, just note that one. And moreover, we are able to see that f primed at 2 is equal to what? Okay, f primed at 2, because f primed at x is this, and at 2 is going to be minus that 3 squared plus 12 times 2 minus 9. Okay, let's do this one here. And therefore, what we're able to see here is the fact that this is f primed at 2, which is equal to exactly 3. Okay. Now, which means therefore we are able to see something using the formula y equals y minus y1 is m into x minus x1. But obviously this the passes through the point. Passes through the point when x is 2 and y is 2, which is x1, y1. So y minus 2, which is the slope, right? The slope then is 3 into x minus 2, which means y is 3x. This is exactly minus 6 plus 2, which is actually a minus 4. So we need to determine the equation of g, and we're able to see, therefore, that the equation of g is exactly that. Okay, it's exactly that there. It is 3x minus 4 because we determined the equation of g. It is exactly that. And there are a couple of ways that we can use to determine this question there. So take note of that. Right, in the next question, we look at 8.5, calculate the value of theta, the acute angle formed between G and the x-axis in the first quadrant. So now let us look at that, because we know that G of x is 3x minus 4. Sure, they were balancing the marks here, just adding 2 marks, a very simple question. But if there's a line like this with a positive slope, which is G of x, which is 3x minus 4, the angle theta, which is formed between x and between G and the x-axis in the first quadrant, this angle called it theta, that would mean that the tangent of theta is the same as the gradient, which is 3 exactly here. And therefore, we have theta, which is actually arctan 3, and theta, which is arctan 3, is actually 71,57 degrees. 71,57 degrees. So to calculate the value of theta, the angle, the acute angle formed between G and the x-axis in the first quadrant, so that angle is 71,57 degrees. Next point. Right, next we want to discuss question 9, which is very important. The diagram below represents a printed poster. Now, rectangle ABCD is part on which the text is printed. ABCD, so this text printed here in the gray part. The shaded area ABCD is 432 cubic or rather square centimeters, and you have that your AD is actually exactly X centimeters. AD is X centimeters. Now ABCD is 4. ABCD is 4 centimeters from the left and right edges of the page. Okay, you can see 4 here, and you can see, and 3 from the top and bottom of the page. 3. You can see that. Show that the total area of the page is given by this. You need to show that the total area of the page is given by that. So, right. So the couple of things that we need to take into account is the notion of what we call the area. So the area of this is given by the following. So if the examiner has already said that AD is X, so it means that moving from here to there is X, but this is 4, and this means that is X plus 8. Okay? Take note of that. And then now, this one you can call it, so this is like the length, and this you can call the breadth. So in the end, if this is the breadth, you can actually look at the fact that area is length by breadth, and the length is X, the breadth is B. Right, this shaded area is 432, so that in the end, this area is 432. Dividing by X, it means that we have 432 over X, meaning this breadth is 432 out of X. Right, so at this point, we need the area as a function of X, which means the area as a function of X is length by breadth. And what is the length? So the length of this is going to be exactly X 4, which is X plus 8, which is the length. The breadth of this is also going to be exactly, the breadth is actually B plus 3, 6, because now we're looking at the breadth, this whole thing. So it's going to be 3 plus 3, which is 6 plus this breadth. Okay. And this is X plus 8, and it is multiplied by the breadth, which is 432 out of X plus 3. Okay, I'm trying to finish these questions, which is A of X. Okay, so if you multiply everything out, it means that A of X is the following. Let's multiply X times this is 432. This X times this. X times 3, which is 3X, plus 8 times, right? 8 times 432 is actually 3, 4, 5, 6 out of X. And 8 times 3 is it 24? Okay. Once again, this one is 6. Okay, because this is B plus 6. B plus 6, and also this one here is a big 6. Just take note of that. It's a big 6. So that 8 by 6, okay, because 8 by 3 is 24, so this is going to be like a 48. It's going to be a 48 exactly. 8 by 6 is 48. Okay. Right, so see that we have exactly these there. We have exactly these over there. What then do we get? What then are we able to get? Okay, so in the end then we get the following. Okay, so The area which is a of x. What is 432? 432 plus 40 is 470, and with the 8, which is, and the 2, which is 480. But now then we have this one, which is 3456. 3456 out of x. And we have this one, okay, because it is x times 6, so it must be exactly 6x. Take note of that. So this is exactly 6x, okay, because it's distribution. X times this is 432, x times 6, 6x, 8 by that, and 8 by that. So it is exactly this, okay, which is 3456 out of x. And this one is plus 6x plus 480. 480. Okay, so that's something that you get there. That's something that you get. Okay, just take note of that. Okay, now in 9.2, determine the value of x such that the total area of the page is a minimum. Right, just look at that one. So in 9.2 now we have a of x. Okay, we already know that a of x is 3456. You divide that by x plus 6x plus 480, which is a of x, which is 3456x to the minus 1 plus 6x plus 480, which is exactly minus 3456x to the minus 2 plus 6. Okay, so yeah, this you can write as, okay, this is the derivative because you bring minus 1, you multiply by this, subtract 1, which is minus 2. The derivative of this, of x, becomes 1. So this is 3456 out of x squared plus 6. Okay, and this is equal to 0 for minimum. Right, if you cross multiply everything, it is 3456, which is 6x squared. Which means, therefore, that you have x, which is 3456, you divide by 6, and simultaneously you take the square root. All right, so divide by 6 and take the square root, so that our x is actually, so if you do 3456 divided by 6, you get 576, and if you take the square root, is 24 centimeters. 24 centimeters. So obviously we need to determine the value of x such that the total area is the minimum, and we can see therefore that x is 24 centimeters over there. 24 centimeters over there, and we have exactly that part there. Next question. Right, in the next question, we are going to just be doing some basic probabilities. Let's just do some basic probabilities as we need to learn them. Right, now A and B are independent events, and the probability of A is 1/3, the probability of B is 3/4. We need to find probability of A and B. Right, at this point, we want to find the probability of A and B. So obviously these events are independent events. So for independent events, we know that the probability of A and B is equal to the probability of A times the probability of B, which means that the probability of A and B is equal to, what is the probability of A? Is 1/3. The probability of B is 3/4. The probability is 3/4. So, okay, we divide. So the probability of A and B is actually exactly 3 cancels, giving us 1/4. So the probability of A and B here is exactly 1/4. The events are independent, and this is the probability of A and B is the probability of A times the probability of B for independent events. Right, for independent events. Okay, let's look at now the 10.1.2 part. 10.1.2, P, the probability, rather, at least one event occurs. At least one event occurs, which means that you have the probability, right, of at least one event occurring. So it means that it is the probability of A or B. Either A occurs or B occurs because at least one event occurs. So it's the probability of A or B, which means that if they say the probability of at least one event occurring, it means it is A or B. Okay, because it's either A or B that occurs, which means it is the probability of A plus. So here you use this formula, probability of A plus probability of B minus the probability of A and B. Right, I know I'm running beyond time. Okay, I'm trying to finish this paper. So the probability of A or B, and the probability of A here is 1/3. The probability of B is 3/4. And we have minus the probability of A and B. We've already got the probability of A and B, and we got the probability of A and B to be 1/4. So we plug this in here. Right, if we add everything here, without any doubt, it becomes 5 out of 6. So that the probability of A or B, and this is the probability of at least one event occurring, is 5 out of 6 precisely. Next question. The probability that it will snow, excuse me. Right, the probability that it will snow on Drakensberg Mountains in June is 5%. Okay, so take note of this because this is going to come in your exam. These probabilities and the independent events and the tree diagrams and the Venn diagrams. So you need to take note of this. We had to do like lots of these, right? But I'm trying to run through as many topics as possible. So the probability that it will snow on the Drakensberg Mountains in June is 5%. When it snows on the mountains, the probability that the minimum temperature in central South Africa will drop below 0% is 72%. If it does not snow on the mountains, the probability that the minimum temperature in central South Africa will drop below 0% is 35%. Okay, so we continue. In 10.2.1, represent the given information on a tree diagram, clearly indicate the probabilities associated with each branch. Okay, so we have the following. So at this point, the examiner is saying represent the given information on a tree diagram, clearly indicate the probabilities associated with each branch. Okay, so this is what we're going to do here. So it is either it snows or there is no snow. Okay, so we know therefore that the probability of snow, okay, the probability that it will snow on the Drakensberg Mountains is 5%. Dividing that by 100 is 0.05. Right? So if what is the probability that it does not snow? The probability that does not snow is 1 minus 0.05, which is equal to 0.95. 0.95. It's like 95% that it does not snow. Okay, so if they say the probability that will snow is 5%, the probability does not snow is 1 minus that. Okay. So now, when it snows on the mountains, the probability that the minimum temperature in central South Africa will drop below 0% is 72%. Okay? And if it does not snow on the mountains, the probability that the minimum, so in other words, it's either it snows or it doesn't. If it does not snow on the mountains, the probability that the minimum temperature in central South Africa will drop below 0% is 35%. Right, so represent these on a tree diagram. Right, so now let us look at the following. So either it snows or there's no snow. Okay, so obviously at this point, we take note of the fact that when it snows, so yeah, it snows. When it snows on the mountains, so there's snow. When it snows on the mountains, the probability that the minimum temperature in central South Africa will drop below 0 is 72%. Divide that by 100, getting 0.72. And the probability, So if we're saying when it snows on the mountains, the probability that the minimum temperature in central South Africa will drop below 0.72%. If it does not snow, so you'd have 1 minus the 72, the 0.72, which is 28%, which is 0.28. Okay, so if it does not snow, right, if it snows or there's no snow, and we are saying if it does not snow, the probability that the minimum temperature in central South Africa will drop below 0 is 35%. So you have 35%, you divide it by 100, becoming 0.35. And obviously, we are then saying that the probability that the minimum temperature in Central South Africa will drop below 0% is 35% if it does not snow. And otherwise, here it will be 1 minus, so if there's no snow, 1 minus 0.35, which is 0.65%. Okay. Right, so yeah, that is the tree diagram in 10.2.1. So we're done with that part. Okay, let's look at the next question in 10.2.2. Okay, yeah, we're done 10.2.1, and then we're looking at 10.2.2. And want to calculate the probability there. The probability that the temperature in central South Africa will not drop below 0% in June 2024. So let us start and remind each other. Either it snows or there is no snow. Okay, the probability of snow is 0, that. We drew this one already, and is 0.95 here. Either there's snow or there's no snow. 0.72. Okay. Okay, this one is 0.72. And this one is 0.28. Okay. Snow or no snow. This one is 0.35, 0.65. Okay, good. Now, calculate the probability that the temperature in central South Africa will not drop below 0%. So now to do that, we're going to say that the probability not below 0%, not below 0 degrees, excuse. Not below 0 degrees Celsius. Okay, not below 0 degrees Celsius temperature. So this is the following. Okay, let me write properly here. We mean 0 degrees Celsius, like so. Okay, good. Right, so this is going to be the probability of the following. I feel like I need to move this a little bit to the left, so that you have the probability of not below the 0 degrees Celsius, which is the probability of snow. Probability of snow. Okay, so not below 0, because the probability that it will snow is 5%. Okay, so the probability of snow not below 0 degrees Celsius plus the probability of no snow not below. So yeah, we were looking at the fact that it can, in two cases, it can snow and you might have that temperature that's not below 0 degrees. All right. So at this point, then what is the probability that it snows? Probability of snow is 0.05 times the probability of not below 0 degrees. Okay, the probability of not below 0 degrees. Right. Probability that the temperature in the central will Right. When it snows on the mountain, probably that the minimum temperature in central South Africa will drop below 0. Okay, yeah. So here you can come here and do this and say below 0, not below 0. And here you can come and say below 0 and not below 0. Okay, so yeah, take note of that, not below 0. So that in the end, when you say when it snows on the mountains, the probability that the minimum temperature in central South Africa will drop below 0 is so the below 0 is 72%, which is 0.72, not below 0. So yeah, same thing there. So you can put the below 0, not below 0. In the same way here, just to be systematic, and then here you can also put here below 0, not below 0, but also here you can put below 0, not below 0. You can put here below 0, not below 0. So that here you can then say the probability it snows is 0.05 and then not below 0. All right, so you put not below 0, and not below 0 you can see is 28% plus. And then the probability of not snowing is 0.95. Okay, so you're looking at a tree diagram here. Okay, you can use some parentheses, but you can use a cross. Right, so which means that this is 0.95, the probability of not snowing, times the probability of not below 0. Okay, it might not snow, and not below 0, it's 0.65. Okay, so it can either snow and be below 0 or not snow and be below 0. And if you use a calculator, you get that the probability of not below, okay, the probability of not below 0 okay, yeah, is 0.6315. 0.6315. Okay, so the probability that the temperature in central South Africa will not drop below 0 degrees in June 2024 is actually 0, comma that, or you can multiply by 100% so that it's yeah, you can multiply by 100, 2, so that it is 63.15%. Okay, let's continue. Next question. Right, now 10 letters stand randomly in a line, one behind the other. In how many different ways can the 10 letters stand in the line? Okay, so 10 letters stand randomly in a line. Okay, they stand randomly in a line, one behind the other. So there's Lena 1, Lena 1, Lena 1, Lena 2, Lena 3, and they're random. They're random. Okay, in how many different ways can the 10 learners stand in the line? Okay, they can stand in the line in the number of the total number of elements in the sample space. So they can stand in the line in 10 times 9 times 8 times 7 times 2 times 1, which is exactly 10 factorial. So they can stand in the line in 10 factorial ways. Okay, take note of that. Now, look, and the next question. Okay, yeah, so this one we say it's the factorial. Number of elements in the sample space will be in 10 factorial ways. So in how many different ways can 10 learners stand in the line in 10 factorial ways? Now, calculate the probability. Okay, let's look at the next question. So if this one here, number of the elements in the sample space is 10 factorial ways that the learners can stand in the line. Why is it like this? It is like this because the first learner Right, and they randomly stand in a line. But now the first learner can take the first position. Okay, sorry. Or you can extract from the group of the learners. The first learner can be chosen in 10 ways. After the first learner has been chosen in 10 ways, we are then left with a group of 9 learners. The other learner can be chosen from 9 learners in 9 ways. After that, you have 8 learners in a group, and you have that the learner can be chosen in 8 ways until you have 1 way to choose the last learner. Okay, look, we continue. Okay, now in 10.3.2, calculate the probability that there will be 5 learners between the 2 youngest learners in the line. Calculate the probability that there will be 5 learners between the 2 youngest learners in the line. Okay, let's look at this particular question. When they say you need to find the probability, calculate the probability that there will be 5 learners between the youngest, between the 2 youngest learners in the line. Okay. So now, obviously, this one here is going to be done with 4 options. There are going to be 4 options. So, which then means that at this point, what we then have is the following. Right. So if we then say we want to find the probability that there will be 5 learners between the 2 youngest learners in the line. Right. So the couple of things, obviously, that we need to take into account here, that we have a total of 10 positions. Right. So if you have a total of 10 positions, we can proceed as follows. So you can take the 2. Right. So in other words, now if you have the 2 youngest learners in the line, so the 2 youngest learners in the line can be chosen in exactly 2 ways. After those has been chosen, you're left with 8 learners. And the 8 learners now can then obviously be organized as well in the line in 8 times, 7 times, 6 times, 5 times, 4. Okay. Then would have times 1 because would have fixed those 2 learners there, times 3 times 2 times 1. And if you multiply all these on a calculator, it's 80,640. Right? So in other words, we have the fact that we want to calculate the probability that there will be 5 learners between the 2 youngest learners in the line. Right. 5 learners between the 2 youngest learners in the line. So I want us to fix the positions. So if we fix these particular positions, and here we have 2, 4, 5, and we can see that therefore we have 5 learners, and these 5 learners are between 2 youngest learners in the line. Okay, so now we also have that here. We can also have that these 2 youngest learners, if we fix the 2 youngest learners and we're left with 8, okay, then you have 2. You have 2 youngest learners. Then, all right, we put one of the learners here. We put one of the learners there. And then you'd have 7 times 6 times 5 times 4 times 3. Okay, if I've put the youngest learner here, and then we put another one. These are 2, 4, 5 learners. We put the youngest one there. Okay, so we've put one young learner there. We put one young learner. So these are 2, 4, 5 learners. We put 5 learners between the youngest learners. In which case, therefore, we're putting 5 learners there, and then we continue to then say multiplied by 2 times 1. So obviously, all in all, we're dealing with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 positions. And therefore, this is still 8640. Next, we fix the 8 learners, and we separate the 2 and left with 8 learners, and then it's 8 by 7, and then we put one learner here, the youngest learner, in this position. Okay, and then we have 6 times 5 times 4 times 3. Okay, learner 2, we've already put them there. Learner 2, we've already put them there. And then here, you put 1, because learner 2, we've already put them there. And then now, we're gonna put learner 1. Let me just write clearly here. Then we're gonna put learner 1 here. Okay, yeah, we're gonna put then learner 1 here. Okay, yeah, we're gonna put learner 1 here. Then, okay, yeah, in the end, then this is 8640. Okay, now let's look at this. Now you have 8 learners. We have separated the 2. Out of the 10, so you're left with 8. Then the rest, the 8, you can organize them in after you have put the learners, you can organize them in 8 ways, 7 ways, 6. Then we can put learner 2 here, for example. Put learner 2 there. Right after you have put learner 2, you're going to put learner 5, learner 4, learner 3, learner 2, learner 1. Okay, so you have this. So this is therefore equal to 8640. 8640. Okay, so in the end, we have these numbers like that. So the total number of possibilities, is equal to, right? So if you add all these things, you add all of them, you have 3,2,2,5,6,0. Okay. So what is then the probability that the examiner wants here? So I'm going to write that one in green. So we're able to then say that the probability of 5 learners, okay, the probability of 5 learners, just finishing this, the probability of 5 learners in between is going to be exactly 3,2,2,5,6,0. Okay, yeah, 3,2,2,5,6,0, you divide by that. 322,560, which is this divided by 10 factorial. And this, if you simplify, is exactly 4 out of 45. So this is the probability. The probability is therefore 4 out of 45. In each case, we're able to see that we're able to put 5 letters. Here we have 1, 2, 3, 4, 5 letters, 5 letters, 5 letters there. And we have found, we've calculated the probability that there will be 5 letters between the 2 youngest letters in the line. Okay, and now because of that, we have reached at the end of this question paper. Thanks a lot for joining us. Right, and I'm going to see you at 8 p.m. And from us, goodbye for now. Goodbye.